Thank you very much. My name is Feja. I am a sales director for Netvibes, which is our data science, data analytics tools inside a 3D experience platform for Asia. So we are here because of data, and I think primarily what we do in general, I think in Dassault in general, is data, data, data. So we have moved from kind of writing data on small parchments to moving to libraries where we're storing data in various different categories, alphabetically, by different subjects and so on and so forth. Today, where there's data everywhere. And we are all trying to make sense out of it, and it's moving faster and faster and faster, and there's more and more data, and we are trying to take this data, which is highly unstructured at the same time, put it in some kind of format that we can understand to help us make decisions to operate our business more efficiently, less risk, and so on and so forth. And I think that's why we're here. And you see kind of key trends that are happening in industry today, which is the artificial intelligence, machine learning, modeling, how we communicate with each other. Also, one of the things that we are all about in Dassault, and you'll see this in a second, is virtual twin. Is that right? You heard a lot about it, and how that represents inside a metaverse, which we're moving slowly towards. Okay? So ultimately, and you will hear this from me across, I have a couple of presentations for you, a couple of slides, a couple of videos, so on and so forth, but ultimately it all comes down to a very simple process that's actually very hard to implement. It's gathering data from all the sources that you need to gather that are relevant to you and your companies. Putting it all together in some form of a structure, and then putting all the relationships, putting all the models, applying all the AI, applying all the machine learning on that, and then kind of presenting that in a format that makes sense. It's a down-top approach, but if you truly want to be successful at this kind of, what we're going to show you, it has to be top-down approach. You have to kind of fully understand, what am I trying to accomplish before I do all this? I've spent many years in this kind of data-centric system. Even before this, so I worked for many different data companies that promised miracles. Is that right? That's what we want here. Here's all my content. Do some magic with it and then tell me all about it. Well, that's really not how it works. I think if you don't have this proper approach of what am I trying to solve and where's data coming from and all the stuff in between, whether it's machine learning or AI or so on and so forth, will come. So I'll show you some of the examples. All right, so I'm going to show you, next slide is a video that explains what is virtual twin. And that's, I think, very important for us for Dassault in general. But I used a very, very simple example. The example that we all know what it is. And now, first let me just kind of tell you, and then I'll just show you. It is gathering virtual data, which is the data sitting in all these different systems, with IoT data, machine data, 3D data, all this stuff, bringing it all together, applying different kind of data analogy to it, whether it's AI, whether it's machine learning, whether it's ontologies, whether it's semantics, all, maybe applying it all together, and then providing it in a format that allow us to collaborate. Because it's not just enough to see the data or see what's happening, but to do something about it, which is where the 3D experience platform comes. But before that, before I show you those examples with Dassault, I want to show you what's a most basic example of virtual twin, something that we, all of us here, take for granted. And that's maps. So here we use Google Maps, somewhere else maybe we use Baidu Maps, Apple Maps, different type of maps. However, so if you take a look at the map, and I'll let this play so you guys can look at it. If you can take a look at the map today, and I want to go eat dinner tonight, I'm going to go, give me 5-kilometer radius, hot pot restaurant that's highly rated, and it's going to give me everything I need. It's going to say, from here to here, 5-minute walking, there's 20 hot pot restaurants, all this stuff. So it's bringing all the data. So for us, the digital twin is representation of something inside the system. So it's data. But you need to take this data and put it all together. So I'm taking the maps, I'm taking how to get there, I'm taking restaurant information, I'm bringing it all together, and I'm presenting to you, a user, a very simple interface that allows me just to say, oh, I can drive there in 2 minutes, I can take an Uber in 3 minutes, or Didi, I can do walking in 20 minutes, traffic changes every minute, it's live, it's giving me information, and I can get there very quickly. That's a virtual twin. This is the most basic example of a virtual twin that we can think of. Maybe there is some more, but this is it. So it's not just maps. This is not maps, is that right? If you remember 10, 15 years ago, maps was I want to go from A to B, and then it'll tell you, but it didn't have real life data of traffic. Then suddenly it has a real life data of traffic. Then suddenly it's telling me, but you know what, around where you're going is going to be 20 restaurants, and they're open till 9, and they're closed at 10. Oh, you can walk here, you can do it. So suddenly map is becoming something much more complex that we get used to every day. I'm sure everybody uses it here. I used it last night to eat in a near restaurant that wasn't closed at 11 p.m. And they had good reviews. That is a virtual twin. So that's the most kind of simple example of virtual twin. That's what we want to do for our customers or partners, ultimately. So when you hear us, Dassault in general, and I'm sure you heard this many times, speak about the virtual twin, that's what we mean. So let me talk about, so instead of me talking about this, I just meant to give you 2 examples of a virtual twin that we did at 2 different customers. These are just examples. The idea is to give you, kind of make you think about what can be done. And we have done many examples, and some go from extremely complex to something in between to something kind of beginning stages. All right, so this example is from a really, really big car manufacturer, OEM, for what we call material cost intelligence. So in this world, the supply chain changes constantly. And we have what we would call supply chain volatility. So everything is volatile. Price of something can change from today to 6 months from now by 20%. So I want to do what I want to know. I want to run what-if scenarios on how that changes my product and the cost of that product and what can I do about it. And it's not just about that, it's about collaboration between my procurement, between my design engineers, between my data engineers, between my purchasing, and all these things in between. So let's run that. I'm gonna let it run, and I'm gonna talk, just kind of, you guys can take a look at it. All right. So this is very simple. We wanna run what-if scenarios if aluminum goes up by, let's say, 10%, or goes up to 150 something in a certain amount of time. So I think this is it. So we have all the products that we make, in this case cars. We have these cars, we have all the data, in this case is how all the materials, in this case is materials, can be anything. And then we also have the 3D, you see a 3D virtual twin here. And then we will run what-if scenarios in a risk management inside the platform on what if it happens if material goes up, aluminum goes up 250. Suddenly we see the impact, it's going to impact us about 1,000 K per vehicle. It just calculated this automatically based on all the data that was bringing, all right? So suddenly we have this ability to look at, okay, if the aluminum goes up, our price goes up this much. So now, based on, because we have here, and if you can see here, we have the ability to not just look at it by data, we can look at it in 3D. Let's look at all the materials that is affecting, that's going to be affected by the aluminum cost. So these are all the aluminum parts, and we have the ability to see, okay, all these parts are being affected. It's, by the way, that's also actionable. Okay, so let's now look at what is the most the most important piece, the one that's going to increase this cost by the most. And that turns out to be a bracket. So if you guys saw, there was a bracket here. We buy about 20,000 of those brackets a year. So suddenly what we want to do, how about we just take this bracket and push it out to procurement to see if they can solve this problem. For example, hey, this bracket, if the price goes up in aluminum, our price goes up 1,000, let's push it to procurement. Procurement can look at it and see if they can maybe potentially solve this what-if scenarios or reduce the price. So procurement can go take a look at all the suppliers. So once again, if you guys follow me here, it's just that it's all about grabbing the data and putting data together. So now we're looking at all the suppliers, what did we have purchased from them, so on and so forth. And over here, we have an issue assigned to us that brackets price increase due to aluminum increase. So we can actually take this and look at this issue, and now we can actually go inside and take this issue and take advantage of some machine learning, and this is the AI, what you're looking at here was going to say, I want to see what other options I have if I need to change this bracket. So it's going to run, it's going to actually take a look at, I'll address this maybe a little bit later what kind of tool this is, but there's a 3D search engine built in automatically that combines all the data, all the stuff that we bought before, that we have in our system, that our suppliers have in their system, and run the comparison and tell us, there's two other options you can look at that might fit the bracket replacement. We can go deeper now and say, okay, this bracket costs this much, this bracket is this weight, this bracket might work, this bracket not, give me 100% similar parts here, so on and so forth, until I find, and in this case what's going to happen is going to find a bracket that fits, that's a little bit cheaper, and potentially it's not made out of aluminum anymore. Those are all the examples here that the procurement can play with. Once they select this bracket, and you guys will see this, it's doing it right now, it's actually going to send it to a simulation engineer that's going to take this bracket and run simulation to see if this bracket would actually fit on a car. So going back to the simulation, so you can run the simulation to see, will this work? Because you guys know in car, highly regulated industry, aerospace or automobile, highly regulated. If we put this in a car, this is a 5 to 7 year part that we need to take care of, life cycle of the part. So he's going to run simulation. If it works out, if not, he can maybe choose another one. There can be multiples. And then he can take this and push it to a data engineer to put it in the design. So now, ultimately what's going to happen is, I am mitigating a risk if aluminum goes up 200% or maybe 20%, instead of me having to raise the price of my car by 1,000 euros or whatever, I can now reduce it by making this. So there was a one what-if scenario. So what I wanted to talk to you, and I'll let this play a little bit more, but I wanted to talk to you about this. Ultimately, what we want, this is machine learning in a background. This is AI, is that right? And I'll show you the models that we built here. But what's happening is we're pulling various different data sources everywhere. And then we're creating what they call data models for these scenarios. And then we're running these scenarios where we're determining how to save money based on supply chain volatility. And that's been a big thing, especially last 2-3 years with COVID and everything. So the supply chain has quite a bit up and downs, is that right? You saw the price of steel, aluminum, and so on. So one of the things that we do that too, when we combine data, and I'll address this also in a second slide after this, there is ontology that gets built whether automatically or we know the market, automobile or aerospace is a big thing for us, high tech and so on. So we create these ontologies that we have ability to build into this, okay? So that was an example, very complex example. I mean, I admit, it's a very complex, but imagine how much money can they save just by running this one what-if scenario. What if aluminum goes up by 20%? It happens all the time, is that right? You guys saw the price of steel go up 80% a year ago. everybody has to increase the price of their product and so on and so forth. This allows them to save it, or save maybe 20–30% out of the cost or so on and so forth, okay? Another use case is construction company. Whether it's OEM that does the maintenance on the construction, whatever it's on a building, platform, and so on, or whether it's a construction company that builds these products. So in this case, it's a water treatment plant, but it could be an offshore platform. And if you guys, so we have one of the largest, second largest in the world construction company, it's Larsen & Turbo. They utilize our product. It's a public knowledge. They've done many speeches on that. It's all about, when they build stuff, it's all about procurement, construction, and engineering, and having to bring all those three together in these millions of small tasks that lead to this very large task of finalizing building the platform. So it's all about ability to see how things affect me on the fly. If something is not being delivered on time, how's that affect these 100 other tasks that are ahead? And what if I need to change something and so on? On the other hand, this water treatment plant, it's maintenance of this thing. How does the maintenance of this thing affect me? So I'm just going to run it through. So in this case, there's enormous amount of, if you guys can see, let me click on this, you'll see program director is taking a look at what is happening with my water treatment plant currently. So I have the 3D visualization. I have all the data, all the KPIs that are associated with this. And what's going to happen here, I'm going to take a look at a couple of things that are red. In essence, they can be red here, or they can be red here. But what's ultimately, what I'm going to see here in a second is I'm going to see a pump that is not performing to the standards. So by the way, the data here, and I think you guys saw it, it's coming from ERP, it's coming from the maintenance system, it's coming from CMS, it's coming from 3–4 different systems. So it's all bringing it together to combine, to give you this view that, hey, there's something wrong with these pumps. They're not performing well, they're taking too long, too much power, too much energy, the IoT on it, the heat is bad. What is going on? And then how this is going to affect, this is a big one, how this is going to affect my maintenance schedules. Because if these things don't get fixed, there's like 20 other things behind it that are waiting for this to get fixed. So if you guys saw, the lady just assigned inside 3D Experience Platform an issue or change, say, hey, take a look at this for me, please. There's something wrong. And the program director here is going to take a look at this, based on all the data coming from all the different systems, figure out the problem, figure out how that's going to affect everything, because we have to now order these specific parts from somewhere else, and it's taking a little bit too long for us to solve this, and adjust the schedule on the fly. So suddenly everything kind of gets, maybe we're late 2 weeks instead of 5, and so on and so forth. So this is an example specifically here in construction where it's driven by tasks. Everything's a task, project. And I need to figure out very quickly, is one thing that's messing me up going to influence 20 other things ahead? And that's once again done with the data aggregation, data analytics, and I'll talk to you about it in a second, how machine learning and AI, and all these things. But also, I want you to notice one thing here of all these two examples that I showed you. Everything is done in the 3D Experience Platform. Every single step is taken. We're not emailing anybody. We're not saying, can you look at this? It's all captured inside. I'm doing it all from one place. I'm doing my analytics, my machine learning, my data views inside together with the 3D, together with the virtual twin, and then I'm sending it off to somebody to fix it, dragging and dropping pumps and so on and so forth. This is what we mean when we say virtual twin for us. It's this whole platform. It's not just analytics by itself. It's not just change management by itself. It's not just issue management by itself or risk management. It's all combined in this thing. So that's very important because traceability is there. So you can always go back, hey, who messed with my pump? What happened here? Or, you know, what happened with aluminum and who decided to change this? Oh, well, Joe, somebody sent an email. No, it's in here. We know exactly what happened, why it happened, and what was done to fix it. Everything is captured inside. So how this is done is Netvibes specifically, we provide what we call 3D Experience Semantic Lake. And that is the set of tools for data manipulation, in essence. So you have, you know, obviously gathering data, whether it's real world or, you know, virtual. We have modeling, so you can run specific models, you can, you know, create ontologies, you can do taxonomies, there's a semantics, you know, and then there's intelligence built around that kind of brings it all together. And then the key aspect here is this actionability, which is seamless integration into everything that the 3D experience platform provides. It's in essence one big product, is that right? So that you can literally, as I'm taking a look at my issues, I'm looking at my issues analytics and changes, and I'm just dragging and dropping them and just working it all together. All right. One other thing to mention, and sorry, actually I'll go back and before I do this. One other thing to mention that's really important for us is where's data coming from, because data integrity, or I guess data how valid the data is extremely important, because if you can't trust the data that you're analyzing, that you're modeling, that you're learning on, then, you know, it's useless, is that right? Because we have issues with, you know, ChatGPT is amazing, what it did to the AI, but if you guys saw just recently there was a problem where somebody filed a lawsuit based on this use case that ChatGPT created for them, but turns out it was fake. But nobody checked it. So this lawsuit actually all the way made it to the judge in the court, and then finally somebody looked it up and says, oh, but this doesn't exist. The ChatGPT just made this up. That's those type of mistakes, when a company makes them, like these type of companies, it's $100 million mistakes right there. That cannot happen. So the data validity is extremely important. Data traceability of what happens to it, it's extremely important. So all the models that are being built inside the semantic lake comes from the sources of, you know, it's a source of the customer. It's always going to be the source of the customer. It's going to be changed on the fly. Okay. So moving right along, I just wanted a couple of slides just to let you know, you saw briefly of one of our key, kind of what I call capabilities. And we call it one part, which is actually a tool that allows you to do what you saw in the first use case, is to do 3D searching, 3D capabilities, in essence taking a look at all your 3D inside, and ability to dissect it, run machine learning on top of it, and analytics, and then create what I call standardization of your parts. So an ability to just create different categories of your parts, clean up duplicates, so on and so forth. On top of that, allow regular users or engineers or designers to reuse the parts that you want them to reuse. Is that right? If I have 20 brackets that are the same, I might want them to use the cheapest one. Or I might, maybe, usually cost is the most important, is that right? So if you look inside of the system, there's a lot of duplicates. I want them to use the cheapest one. You know, I spent some time, there was an aerospace discussion, I spent a lot of time aerospace. There's somebody that don't care about the cost, because it's going on a satellite that's gonna go in space, it's gonna stay in space for 10 years, 20 years. So I don't care about the cost, I care about the quality, so I want it the highest quality, or so on and so forth. So you can create these classifications, categorizations that push through the engineers and designers to reuse. Okay, so that was wanted to just to bring that up. That was kind of you saw that when we were doing the parts bracket part inside of the car. Okay, and I think these are some of the. So I just wanted to bring this side. So we obviously virtual twin can be a very expansive story, but also you start small and you build it up, but you have to start it. And these are some of the use cases that we have done and some of the savings that our customers realized. I mean, you guys can probably see, but the material cost management is just by running what if scenario in aluminum, we can save a lot of money to the customer and so on. So there's a lot of different use cases. I just wanted to kind of bring this up because these are all the different use cases that we have done, various different aspects of the virtual twin, maybe beginning to the very complex one, and so on. Okay, so I think Ben,
好，那我这边大概做一个简单的总结哈。我想在这个主题里面，我们是在谈到所谓的资料科学。好，那在这个过程里面，其实大家做了很多的这些资料。那其实我们都知道，我们如果从 data 变成 information， 变成 knowledge， 更难的是什么 ？know-how。好，那其实从这样子的一个情境里面，也可以看到说，最底层的这一块，就是我这些所有资料 evaluate， 就是我如何从这些地方去收集出来，去做一些运算。那我想这个是大家现在在谈到所谓的 AI、machine learning 在做的事情。可是这都是什么？片段的。我们回过头来看这些事情，我们在看这一些所有的资讯里面，其实一个很重要的就是我们在如何支持我们这些所有主管去做所谓的 decision making。那 decision making 我们希望能够做到的是什么？多面向的一个 decision making。那这样子一个多面向，如果去做到这个事情，其实我们都可以看到，现在大家做了很多的什么战情室 dashboard。我们遇到很多的客户说，我们的 IT 做了很多的 dashboard， 可是老板都看不懂，因为花花绿绿的，看不懂。那为什么？其实从老板的角度来看，这个事情就是我现在的热点是什么？你给我提这一个主意 ，What's the hot topic？ 好，那再下来他会问一个什么问题 ？What if？ 如果有成本的问题嘛，对不对？所以他会问什么 ？What if？ 如果你给我换成什么，会不会这样？可是通常问这句话了，底下人就低着头回去什么？重新提 proposal。再下一个问题就会什么 ？What else？ 还有没有其他的东西？好，那这些事情其实我们如何更快速的去做这样子的一个迭代？那我想这个是从我们现在看到，从达说这边再看到从 data science 如何进阶到我能够真正做到让这些所有的高阶主管或是老板能够做到所谓的这些所有的 know how， 这些所有 know how 能够去把它给在整个一个平台里面去做出来。所以其实从我们前面的这几个主题里面，我们都可以看到，就是说像第一个 use case。cost， 我们看到 cost 很简单，我只是想什么？大家最简单想到的是什么？泵的成本。可是我没有想过，我如果换了另外一个类似的零件会怎么样？我今天如果从另外一个供应商去做这个事情会怎么样？那这些东西原始刚刚从影片里面看到的是什么？我的零件的供应什么成本已经在上升的趋势，所以已经有这个风险。我如何去把这些风险能够把它减低下来？那第二个 use case 在谈的是建筑业里面最重要的，就是我们从一个 program 到展成很多的 project。我们知道建筑业，我们今天灌的那个水泥浆，我一定要等很多天我才可以什么做其他事嘛，对不对？它那个 dependency 跟我们在做产品可能不太一样。我说你做慢的，我可以偷偷做我们做产品也可以做，可是建筑业可不可以？不行。不行，没有那个机会，所以他们在整个 project 或 program management 上面就非常非常的重要。那如果在这个过程里面，这么多的一个，而且是建筑业是一个 ecosystem， 那么多的 supplier 一起在工作，我如果去确保大家都是什么同步的，我今天接到这边的时候，发觉，我怎么做的东西，我这个桥梁要架上来，怎么东西还没到？那你整个就 delay 下来。那我想这个都是从这个地方里面，我们从这个资料科学的角度，我把这个再谈到所谓的 modeling。我把这些东西能够在平台里面去做到这一些所有东西，把它给关联在一起。然后最重要提供的是什么 ？experience。我们今天一直在谈的一件事情就是 experience。我如何让每一个不同角色的人都能够体验到，就是说我这些资料，而且我能够在这些 connected data 都可以什么 一层一层的往下展下来，一个平台能够去 fulfill 到每一个不同角色的人。那我想这个是从这个角度来看。那等一下在下一个 topic 我们再谈到，我们只有这样子而已吗？我们只有能够做到这个事情吗？我们现在在谈到的 ESG 永续发展。那这些事情只有 cost 的这些事情吗？那当然不是。好，所以我想这个在下一个 topic 里面，我们就会再谈到这些更设计，如何从设计的阶段，我们就可以再做到更多的东西，能够在更前端，我就能够去把这些东西把它给串联在一起。好，那这是我大概简单的一个总结。